Alright, hey guys. Right now we're going to do section 6 of chapter 8 for advanced algebra. And section 6 is all about quotients of radicals. So in the last section we talked about multiplying radicals. Now we're going to talk about dividing them and how do you divide a radical. So the first step is you have to rationalize. Remember that whenever you have a square root or a cube root or whatever, some sort of root in your denominator, that is not acceptable. You have to rationalize that and get it out of your denominator. You can't leave it like that. So that's what we call rationalizing. So let's just start by rationalizing a few problems. I've got a couple extra examples here that aren't on your notes, so hopefully they'll help you if you just follow through. First one, we want to multiply the top and the bottom of the fraction by their rational value in the denominator. So in order to rationalize something, we have to get rid of the denominator, and the way we can do that is by multiplying by a fraction using that rational or that irrational number in the denominator. So over here, if I have 3 over the square root of 2, what I can do, I have a square root of 2 in the denominator, so I can create a fraction that's square root of 2 over square root of 2, which by the way is just 1, and multiplying by 1 doesn't change anything, so I know that I can do that. So then if I multiply through, I have 3 square root of 2 on top, and square root of 2 times the square root of 2, that's just the square root of 2 squared, which would just be 2. Okay, so if I want to do it for this one, I know that I need to multiply by the square root of 25 n to the 7th. And I have to do that to the top and the bottom so that I'm not actually changing my fraction. Okay, so on top, I'll have 20 times the square root of 25 n to the 7th. On the bottom, if I take 25 n to the 7th squared, that would just be 25 n to the 7th. Okay, so notice that when you square that, you're just basically getting rid of the radical sign. Now if I simplify this up here, the square root of 25 is just 5. So I can pull a 5 out front. And if I pull that 5 out front, these numbers are going to be multiplied. So that's going to be 100 times the square root of n to the 7th, which I can just rewrite as n to the 7 over 2. On the bottom, I've still got that 25 n to the 7th. Okay, now I can simplify it even more. So 100 over 25 gives me 4. N to the 7 halves divided by n to the 7th, well, this is the same thing as n to the 14 halves. If I divide those, that means I subtract. So this would be the same thing as negative 7 halves, which I know is just 4 over n to the 7 halves. Okay, because we don't like negative radicals in our answer. If you have a negative exponent, you want to make sure that you change that into a positive before you submit your answer. Alright, just a couple more examples here. I know these aren't on your notes, but I'm just going to go through them. You can skip ahead if you want. If I have 9 divided by c square root of c, I know that I need to multiply by the square root of c over the square root of c in order to get rid of that. So up top, I'll have 9 square root of c. On the bottom, c square root of c times the square root of c. If I take square root of c squared, that's just c. So c times c gives me c squared. Okay, that is now in simplified radical form. Okay, over here, I've got 8n over the square root of 6n to the 5th. Okay, so I'm going to multiply by the square root of 6n to the 5th. And remember, you have to do that to the top and the bottom. So then I'll have 8n square root of 6n to the 5th over, if I square that, I just have 6n to the 5th. Okay, now I can go through and simplify. The square root of 6 I can't really do anything with. I could simplify the radical, so I know that, no, actually I can't even do that. But I know that this n to the 5th, the square root of that, that would be n to the 5 halves. So let's see, this would be 8 over 6. That would give me 4 over 3. This is an n. This is the square root of 6, and this is n to the 5 halves. Okay, this one is just 3 n to the 5th. Okay, so if I combine these n's here, okay, this is n to the 1st times n to the 5 halves. If I am multiplying the bases, then I add the exponents. So 1 plus 5 halves, that's 1 plus 2.5, which is 3.5, which is 7 halves. So this is 4n to the 7 halves times the square root of 6 over 3n to the 5th. Okay, 7 halves minus 5, that's 3.5 minus 5. So that would be negative 1.5, which is negative 3 halves. So this would be the same thing as 4 square root 6 over 3n to the 3 halves. Okay. For these problems, notice that I simplified down pretty far. You don't necessarily have to get that far. You just need to know the process of getting rid of that radical in the denominator. So I think that for some of the answers in the book, they might just go down to like this far or this far, which is fine. Eventually, towards the end of the chapter, you will have to simplify these down all the way, so that's why I just went through them and did them all the way. All right. We also can multiply by the top and bottom of a fraction by the conjugate of the denominator, similar to the process used for complex numbers. So remember back in chapter 6 when we were dealing with imaginary numbers, and we talked about how to divide complex numbers. Well, we multiplied by the complex conjugate of the denominator. We can do the same thing with these types of radical fractions, things in radical notation, in order to get rid of those radical signs. So if you have something where you're adding or subtracting a radical in your denominator, you have to multiply by the complex conjugate, which would be like 1 minus the square root of 5 instead of 1 plus the square root of 5. So here's your first example here. If I have 2 over this 1 plus the square root of 5, I know that I would be multiplying by the complex conjugate of that denominator. So that would be 2 over 1 plus square root of 5 times 1 minus square root of 5 over 1 minus square root of 5. Remember that this is the same thing as 1, so I'm not actually changing anything. So then if I multiply that through, here I would just distribute to each part, so I get 2 minus 2 square root of 5. Whereas down here I have to FOIL, so 1 times 1, square root of 5 minus square root of 5, and square root of 5 times negative square root of 5 gives me negative 5. So essentially I have 1 minus 5, which gives me that negative 4. So then when I go through, I can simplify these down. Remember that if I simplify one part, I have to simplify the other two. You can't just divide one part by negative 4 and not do anything to the other part. So if I simplify this down, this becomes a 1, this becomes a 2, this becomes a 1, and I have negative 1 plus square root of 5 over 2. Okay, now if I'm going to go through and do the example, I've got 2 plus 7 square root of 5 over 2 minus 3 square root of 5. I have to multiply by the conjugate of the denominator, so that would be 2 plus 3 square root of 5 over 2 plus 3 square root of 5. Okay, now remember, you have to FOIL with these. So be careful when you're going through. So if I do 2 times 2, that gives me 4. I do 2 times 3 square root of 5, that gives me 6 square root of 5. If I do 7 square root of 5 times 2, that gives me 14 square root of 5. If I do 7 square root of 5 times 3 square root of 5, I know 7 times 3 is 21, and then square root of 5 times square root of 5 is 5. So 21 times 5 gives me 105. Okay, now I can do the same thing down here. So 2 times 2 is 4. Negative 3 square root of 5 times 2 is negative 6 square root of 5. 3 square root of 5 times 2 is plus 6 square root of 5. So notice right off the bat that those cancel. And then negative 3 square root of 5 times 3 square root of 5. My negative 3 times 3 is 9. My square root of 5 times square root of 5 is 5. So negative 9 times 5 gives me negative 45. Okay, so now I can go through and simplify. 4 plus 105 gives me 109. 6 square root of 5 plus 14 square root of 5 gives me 20 square root of 5. And then 4 minus 45 gives me negative 41. Okay, I think that's all I can do there. I don't think I can simplify anymore. So this is going to be my answer. All right, that is everything for section 6.